This is the video for 7.1, and in Chapter 7, we're talking about the rules for exponents. And every day we're going to learn some more rules, and you do need to memorize them. So today we're going to talk about our first two rules. The first rule talks about what to do when you have an exponent of 0. And the next rule talks about what to do when you have a negative exponent. Now, in another lesson, I am going to explain why these rules exist. But right now, I just need you to memorize them. So pause the video and write these down. So first, let's talk about anything raised to the 0 power. Whenever you have an exponent of 0, the answer is going to be 1. Anything raised to the 0 power is 1. So again, pause the video and write that down. You need to memorize it. And again, I will explain why in another video. Okay, and next, anything raised to the negative exponent tells us that the base is on the wrong side of the fraction line. Once again, let me say that again. Pause the video and write this down. Whenever you have a negative exponent, it means that the base is on the wrong side of the fraction line. So a negative exponent is equivalent to the inverse of the same number with a positive exponent. Look at my example here and listen to that again. A negative exponent is equivalent to the inverse of the same number with a positive exponent. So let's look at example number 1. If I have 9 raised to the negative second power, that's the same thing as saying 1 over 9 squared, which is 1 over 81. Remember, 9 to the negative second power is over 1. So what am I doing? Right now, this 9 to the negative second is in the numerator. So I'm going to take it and I'm going to move it down to the denominator, and then I'm going to make the exponent positive. Okay, negative 3.6 raised to the 0 power. The whole thing is raised to the 0 power. So that means the answer is going to be 1. Because again, anything raised to the 0 power is 1. So go ahead and pause the video and work out these on your own practice problems. Here are the answers, so pause the video and make sure that you got these correct. If you got anything wrong, make sure that you understand what you did wrong, and if you're still confused, send me an email. Example number 2. So now we're going to take those rules that we just learned and we're just going to apply them to more complicated situations. So I have 5a to the third power times b to the negative second power. So remember, whenever you don't see an exponent written, that means the exponent is 1. So if I just have 5, that means 5 to the first power. So my 5 and my a have positive exponents, so they can stay where they're at. So remember, this whole thing is over 1. So the 5 and the a to the third power can stay in the numerator. But look at this b to the negative second power. He needs to move, so we're going to put him down into the denominator, and then we're going to give him a positive exponent. So let's look at the next one. I have 1 over x to the negative 5th power. Again, this x has a negative exponent, so that means he's on the wrong side of the fraction line, so we need to move him up into the numerator, and we will give him a positive exponent, because that's the same thing as saying x to the 5th over 1. So go ahead and pause the video and practice these on your own problems. Here are the answers. Again, remember, the only time something needs to move is if it has a negative exponent. If it has a positive exponent, it stays where it's at. And finally, example number 3, evaluating an exponential expression. So it says, evaluate the following when s is 2 and t is negative 3. So you can go about this one of two ways, and one way is not any better than the other. It's all personal preference. So you can plug in the values for the variables first and then start moving things around, or you can go ahead and move the variables around first and then plug in the values. Either way is fine, and it does not matter to me which way you do it. So I'm going to go ahead and I'm going to move around the variables first, and then I'm going to plug in the values. So my 3 and my s to the 3rd are going to stay where they're at. And if it helps you, always put this over 1. 3s to the 3rd times t to the negative 2nd is over 1. So the 3 and the s are going to stay in the numerator, but this t is going to move down to the denominator, and then it will have a positive exponent. And so now I'm just going to plug in the values for my variables. It says s is 2, and then t is negative 3. And use parentheses so you don't get yourself confused. So the top is going to be 2 to the 3rd power is 8 times 3 is 24, and this is going to be a positive 9, but I can reduce that, and that's going to be 8 over 3. Because 3 goes into 24 8 times and 3 goes into 9 3 times. So now you can hit pause and evaluate the following when n equals negative 2 and w equals 5. Here are the answers. Remember, anything raised to the 0 power is 1. So right away, we can say this w to the 0 power, that's 1. We can say n to the 0 power, that's 1. And then you can go through and start moving things around. This n to the negative 4th power needs to go into the denominator. This n here is going to have to go into the denominator. This w is going to have to move and go into the numerator. But remember, you're only moving the variable that has the negative exponent. Okay, so you can go ahead and stop the video and work on your homework and let me know if you have any questions.